Hi, this is Jolien, and we're going to do a circular motion problem. This problem is called rotor ride. In a rotor ride at a carnival, people are rotated in a cylindrical walled room. The radius is 4.2 meters, and the rotation frequency is zero point 0.7 revolutions per second when the room drops out. Our question is, what is the minimum coefficient of static friction so that the people will not slip out? Our first step to solving this problem is by drawing a free body diagram. And we can see here Sophia on the wall, who is experiencing a downward force due to her weight from the gravity in the earth. And then we have a upward force, which is the same amount of the weight, and it's due to the wall. It's a friction force. And then we have a centripetal force going towards the inwards of the ride, which is actually a normal force that is against the wall. So if we go back to our original problem, we know the angular velocity and the radius, but we need to find the minimum coefficient. So we can start off with our normal equation, force is equal to mass times acceleration. And since we know acceleration is v squared over r, we can plug that in, and then the angular velocity is also equal to r times w, which we can plug in, and then cross out the r's, which we're left with a f is equal to mass times the radius times the angular velocity squared. Knowing that our angular velocity is 0.7 revolutions per second, which we must change to radians per second because that is the unit of angular velocity, which we can do by multiplying by 2 pi, so that equals 4.4 radians per second, and then we can use this and plug it into our old formula, which we can get n to equal the mass times 4.2 times the angular velocity 4.4 squared. And since we're looking for the coefficient of friction, we have to get the friction formula in there somewhere, and the friction formula is F is equal to mu times the normal force, and plugging in the normal force, we get G is equal to mu times 4.2 times 4.4 squared, and then we can use this to solve our problem by isolating mu and plugging in a 9.8 for G, and then we get our final answer to be 0.12.